Good day, grade 10s. Today we're going to do some problems that involve proofs, and these are normally called writer's problems. So these are difficult problems to solve, but with a good strategy you'll be able to solve them as long as you can practice them and do more examples and more activities related to this kind of problems, so that you get used to the reasoning part of these problems, because these problems, they teach you how to reason. They teach you how to reason mathematically. So now the first problem says that in parallelogram ABCD, it is the parallelogram that you see here below. The bisectors of the angles AW, BX, CY, and DZ. Now, bisectors are lines that divide an angle into two parts. So you can see those bisectors is AW, BX, CY, and DZ. Right? CY and DZ. And then now, these bisectors, they have been constructed. You are also given AB is equals to CD. AB equals to CD, AD equals to BC, and AB is parallel to CD, and AD is parallel to BC. Angle A is equals to angle C, angle B is equals to angle D. Prove that MNOP is a parallelogram. So the thing that we are proving here is this one. We want to prove that the yellow shape is a parallelogram. So to prove this, we're gonna start first by, in order to prove that it is a parallelogram, if we can show that the opposite angles of that shape are equal, then we can conclude that it is a parallelogram. Or if we can show that the opposite sides are equal and parallel, then we can conclude that it is a parallelogram. So in this case, we're gonna prove that the opposite angles are equal, because we have more information regarding angles in this case. So this is what then we're gonna do. We're gonna say in triangle APD and triangle BNC, these are the triangles that I'm referring to. Then the other one is this one. We're going to analyze these two triangles. It's going to be very interesting. We are given that AB equals to ACD and AD is equals to BC. So now we're gonna start. AD is equals to BC. Reason is given. This one is given. And then we also see that angle A1 is equals to angle C1 is also given. And we see that angle D2 is equals to angle B2 is also given. Therefore, triangle APD is congruent to triangle B and C. And then reason will be what? We have a side, we have angle, we have angle. So reason will be angle, angle, side. Now that we have proved that the two triangles are congruent, therefore, we can say, therefore, angle P1 is equals to angle N1. Reason, triangle APD is congruent to triangle B and C. And then after that, we can say angle P1 is equals to angle P2. Reason, vertically opposite angles. And then angle N1 is equals to angle N2. Vertically opposite angles. Right? Because P1 is equals to N1, therefore it follows that P2 is equals to N2. So P2 is gonna equals to N2. So since P1 is equals to N1 and P1 is equals to P2 and N1 is equals to N2, therefore P2 is equals to N2. Therefore, you can say that P2 is equals to N2. So we have proved that the first pair of opposite angles are what? Equal. So we have proved this. This and this are equal. Now we need to prove that M2, angle M2 and angle O2 are also equal. So how are we gonna do that? Then this is how we're gonna do it. So I'm gonna first identify, we are given that AB is parallel to DC, right? So we are given that AD is parallel to DC. So I see a Z shape. So first I'm gonna say in triangle O is Y Z and triangle MXW. And then after that, I'm gonna show the shape, right? So the triangles we're dealing with here, these are the triangles. These are the triangles. And then now, because of AB is parallel to DC, we see a shape, right? So this is the Z shape that I'm looking for. So I see this Z shape right here. And then if I see this Z shape, I see alternate angles. And because the angles are alternating, they are equal because of the lines that form them are parallel. So it means we can say that angle B1 is equals to, before we can say in triangle, let's remove this. Yeah, before we can do the triangles, let's first deal with the Z shape. So angle B1, I'm gonna say angle B1 is equals to angle MXW, right? Reason, alternate angles because of AB is parallel to DC. So then we know this angle here in this triangle is the same as B1, so we can use the, and then what other angle? And then we see another Z shape, right? Another Z shape that we see is this one. We see this Z shape. Angle A2 is equals to this angle right here. So we're gonna say angle A2 is equals to angle MWX. Alternate angles because of AB is parallel to DC. And then now we can, so these angles that we have identified, we're dealing with focusing on triangle MXW. Now the focus is gonna be on triangle OYZ. Now, when we look at triangle OYZ, we also see the same situation. If you see here, we can see that there's a Z shape. This is a Z shape that I see. Do you see the Z shape? This angle D1 is equal to this angle because of the parallel line. So they are alternate angles that are equal. So then we can say angle D1 is equals to angle OZ. Why? Reason, alternate angles because of AB is parallel to DC. Then the second bullet point, we will identify another so we can see it. This is another Z that I see. This is another Z that I see. Remember, alternate angles, they form a Z shape. So this angle right here is equal to this angle. So then I'm gonna say angle C2. Angle C2 is equals to angle OYZ. Angle OYZ, let me write it well. Angle OYZ. OY. Reason, alternate angles because AB is parallel to DC. And then now that we have this information, right? B1 is, if you look at the shape right there, angle D1, we just showed that the D1 is equals to OZY, right? But angle D1 is equals to angle B1, right? It's given. Angle B1 is equals to angle D1. This is given, right? And then the other thing is that angle A2 is equals to angle C2 is also given. Therefore, B1, we can conclude that angle MXW, where I see B1 I replace with MXW, where I see D1 I replace with what? OZY. but angle MXW is in triangle MXW, right? And angle OZY is in triangle OZY. And then we can do the same with angle A2. Angle A2 is equals to MWX, so we can replace it with MWX. Angle MWX is equals to angle C2. We can replace C2 with OYZ, angle OYZ. Angle MWX is in triangle MXW, and angle OYZ is the angle at Y in triangle OYZ. So we have angle in the two triangles. But because two angles are equal, it means the third angle will always be equal. This is the rule that you must remember. If two triangles have two angles that are the same, the third angle is going to be the same. So therefore we can conclude that therefore it means that it means what? It means angle M1 is equals to angle O1. The reason here will be third angle. And then because of we have proved that these triangles, they have the same angle, right? Because this is also an angle. It means these triangles are what? They are similar. So then we can say that therefore triangle MXW is similar to triangle OYZ, and then reason being angle. So the two triangles are similar. And when triangles are similar, it means what? They have the same corresponding angles and their sides are in proportion. But in this case, we are interested in their corresponding angles, right? So we just showed that angle M1 is equals to angle O1, right? So now we can say that angle, I'm gonna come here, angle M1 is equals to angle M2, reason vertically opposite angles, right? And then angle O1 is equals to angle O2, reason vertically opposite angles. Because angle M1 is equals to angle M2 and angle O1 equals to angle O2, and we have shown that angle M1 is equals to angle O1, right? Therefore it means that we can say that angle M2 therefore is equals to angle O2. So therefore angle M2 is equals to angle O2. Therefore we have shown that the opposite angles, another pair of opposite angles, are equal, right? So then we can make a conclusion that we have this pair of opposite angles and also this pair of opposite angles that we have shown, P2 and N2, right? Therefore it means what? Therefore we can conclude and say therefore MNOP is a parallelogram. And then we have proved that it is indeed a parallelogram. Now next, in the diagram below, AC is equals to EF. AC and EF bisect each other at G. To bisect means to divide into two equal parts. Remember that. So it means if AC and EF bisect each other at G, it means AG is equals to GC, right? And FG is equals to GE. Very important. E is the midpoint of AD. So it means that we also have AE is equals to ED. And we are told that it's the midpoint. Remember, midpoint means that it's at the center. So yeah. So then now, or the mid halfway, or the halfway point on the line. So now E is the midpoint of AD and F is the midpoint of BC. So it means that also this side BF is equals to FC. Then the first question says prove that AECF. So AECF is this one. Prove that AECF is a parallelogram. Do you see that our shape doesn't look like a quadrilateral, right? But it is a quadrilateral because we can construct AF, and this is what actually we are supposed to be showing you. So we want to prove that AEFC is a what? It is a parallelogram. So how are we going to show that? In this case, if we can just show that the diagonals AC and EF bisect each other, then we can just conclude that it is a parallelogram. When the diagonals of a quadrilateral bisect each other, then that quadrilateral is definitely a parallelogram. So then we're gonna write what we are given. So first we are given that so then we have what? We have AG is equals to GC. Is given, and EG is equals to FG is also given. It's given because we are told that we are told that AC and EF bisect each other at G. So that's what we are told, right? And then therefore the diagonals AC and FE are diagonals so they bisect each other, therefore it follows that AECF is a parallelogram because the diagonals bisect each other. And then next, prove that ABCD is a parallelogram. So now we need to show that ABCD is a parallelogram. How are we going to do that? So to prove that ABCD is a parallelogram, we have to show that pairs of opposite sides are equal and parallel, right? So I'm gonna first show the parallel part. So I claim that AE is parallel to FC. Reason? We just proved that what AEFC is a parallelogram. So we know that opposite sides of palm are parallel, right? So we know that the opposite sides are parallel. So I claim that this is parallel to this. Therefore, I claim again that AD is parallel to BC. Reason? Because AE lies on line AD and FC lies on line BC. So then we can say that AD is parallel to BC. And then we have what again? We have that AE, we are given that AE is equals to ED, right? This is given. And then we have AG is equals to GC is given. Therefore, it means that EG is parallel to DC. Reason? Midpoint theorem. And then, therefore, I claim that EF is parallel to DC. Reason? Because of EG lies on line EF, right? And then we are also given that ACG is equals to GA is given. FC is equals to BF is given. Therefore, it means that GF, is parallel to AB, right? Reason? Midpoint. But again, I claim that EF is parallel to AB. Reason? Because GF lies on line EF. Because EF is parallel to DC and EF is parallel to AB, therefore we can combine the two statements and say, we can combine this statement and this statement, and then we can say that AB is parallel to DC. Do you see how amazing this is? This is beautiful. So AB is parallel to DC, right? So now we see that the opposite sides are what? The pairs of opposite sides are parallel. That is very, 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 very interesting. So the pairs of opposite sides are parallel, right? Then we have shown, look, we have shown that AD, this in the first part, we have shown that AD is parallel to BC, right? And then in the second part, we have shown that AB is parallel to DC. So therefore, we can make a conclusion that therefore ABCD is a parallelogram. Why? Because pairs of opposite sides are parallel. So to prove that a quadrilateral is a parallelogram, you need to show the following. If you can prove that the opposite sides are equal, if you can show that one pair of opposite sides, they are equal and they are parallel, you can conclude that it is a parallelogram. Or if you can show that all the opposite sides, pairs of opposite sides are equal, even if you don't show that they are parallel, if you can just show that they are equal, you can conclude that it is a parallelogram. Or if you show that the opposite sides of a quadrilateral are parallel, pairs of opposite sides are parallel, then you can conclude that it is a parallelogram. Yeah, so it means we have shown that this is parallel to this and that is parallel to that, as you can see using the red color right there. And then the next problem, PQRS is a parallelogram. PQ is equals to TQ as we are given. Prove that angle Q1 is equals to angle R. Angle Q1, we can see it here. So we want to show that is equals to angle R. So how do we do this? With this type of questions, to make the problem much easier, we're gonna say let angle Q1. So I'm gonna say let angle Q1, let angle Q1 be X. So we're gonna put X here. It will make things easy. It means that because we put X there, we expect angle R to be X. That's what we expect, right? And we are proving that Q1 is equals to R. So we expect angle R to also be X. So then we're gonna begin. So we are told that PQRS is a parallelogram. So I claim that PS is parallel to QR. Reason, properties of a parallelogram. Therefore, it means that angle T1 is equals to angle Q1. They are alternate angles because of PS is parallel to QR. We can see the Z shape. This is the Z shape. They are alternate angles. So that's the Z shape. This angle and this angle, they alternate, as you can see. And therefore, it means that angle T1 is equals to X. So we can put X there, right? And then we are also given that PQ is equals to TQ. This is given. Therefore, it follows that triangle PQT is isosceles. Because it has what? Two sides equal. Therefore, because we have an isosceles triangle, it means that angle P is equals to angle T1. Reason, base angles of isosceles triangle. So it means angle P is equals to X. So we can put X here. But I claim that angle P is equals to angle R. Reason? Properties of parallelogram. What property are we referring to here? That the opposite angles of a parallelogram are equal. Therefore, it follows that x is equals to r. Therefore, angle r is equals to x. Therefore, we can make a conclusion that q1 is equals to angle r. They are both equal to. Then we have proved. This is the end. That's what we wanted to prove. And then ABCD in this problem, we are told that ABCD is a rhombus with AM equals to MO and AN equals to NO. Prove that ANOM is also a rhombus. ANOM. So we want to prove this, that this shape here is a rhombus. So since angle A1 is equals to angle A2, since angle A1 is equals to angle A2, therefore it follows that angle AON is equals to angle AON is equals to angle AOM. This one is angle AOM. Yes, angle AOM. Yeah. So it means we have this situation now. We have angle A1, angle, this is equals to this angle, and then we can then include angle AO. Also, we have that angle AO is equals to angle, side AO is equals to side AO. This is common, right? So then we have three conditions of a congruency. Do you see? So then we can conclude that we have a situation where this is an angle, this is an angle, this is side. So we can make a conclusion that therefore triangle ANO is congruent to triangle AMO. Reason, angle, side. And then after that, then we can what? Because the two triangles are congruent, right? Therefore, it follows that AM is equals to NO, right? And then reason being congruent triangles. We just showed that the triangles are congruent, and then AN equals to MO. Reason congruent triangles, right? But AN equals to NO given, and AM is equals to MO is also given. Therefore, it follows that AM is equals to MO is equals to AN is equals to NO. So all the sides are equal, right? So once we have reached this stage, we can conclude that it is indeed a rhombus, because we just needed to prove that it's a rhombus, right? So a rhombus is what? It's a quadrilateral with 4 sides that are equal. So we can then make a conclusion. Therefore, ANMO is a rhombus. A rhombus is a quadrilateral with 4 equal sides. That's a rhombus. So we have shown that it is indeed a rhombus. And then problem number 5, ABCD is a parallelogram with diagonal AC. Given that AF is equals to HC, is given as you can see there, show that AFD, triangle AFD, is congruent to triangle CHB. So let's color the triangle so that we can identify them. Triangle AFD is what triangle here? This is the triangle. Triangle AFD. The good news is that we are told that it is a parallelogram. That's a lot of information. Once you are told that it's a parallelogram, you have enough information. And we are proving that it is congruent to triangle CHB. CHB is this triangle right here. So this is triangle CHB. Let me do it so that I don't obscure some information that is important. Yeah, so that's the situation that we have. Those are the two triangles that we want to prove that they are congruent, right? So we are told that AF is equals to HC. So that will be our first. So AF equals to HC is given. So this one is given. And also we see that AD is equals to BC. Reason, the opposite sides of parallelogram, they are equal. Remember, we are told that ABCD is a what? Is a parallelogram. So remember that. And the other thing that I see is this. Look at this Z shape. I'm going to draw this shape so that you can see it. This is a Z shape that I'm seeing. Look. This is the Z shape that I'm seeing. Geometry problems require you to visualize these kind of problems like this so that you can be able to solve them correctly. Do you see the Z shape? And then we know that AD is parallel to BC because it's a parallelogram and we are given. So this angle A1 and angle C1 are alternate angles and they are equal because they are formed by parallel lines. So we can conclude that angle A1 is equals to angle C1, alternate angles, because of AD is parallel to BC. Therefore, we have what? We have side, we have angle, right? Therefore, we can make a conclusion. So therefore, we can make a conclusion and say that triangle AFD is congruent to triangle CHB. Reason, side angle. So we're gonna prove that DF is parallel to HB, right? So in order to do that, in this case, we're going to use, in order to prove that DF is parallel to HB, we need to prove that, we need to show that this angle F2 and angle H2 are equal. They are alternate angles, as you can see. If alternate angles are equal, then the lines that form them will be parallel. So if we can show that F2 and H2 are equal, then we can conclude that the lines are parallel. So we're going to use, to do that, we're going to use the following. So we're going to say angle F2 is equals to, Angle F2 is this one, right? And it is an exterior angle of triangle ADF. You can see that, right? So angle F2 is equals to this angle plus this angle. Remember the exterior angle of a triangle? So angle F2 is equals to angle ADF plus angle A1. Reason, the exterior angle of a triangle. And then angle H2 is also an exterior angle of a triangle. It's the exterior angle of triangle BHC. So then we're gonna say angle H2 is equals to angle HBC, meaning this angle and that angle, when we add them we get H2. So plus angle C1. Reason, the exterior angle of a triangle, right? But we just proved, right? But angle A1 is equals to angle C1. This one was proved. And then I claim that angle ADF is equals to angle HBC. Reason, because the triangles are what? Are congruent. We just proved that the triangles are congruent, right? Therefore, I claim that angle where I see HBC, I can replace it with what? With angle ADF. Where I see C1, I can replace it with angle A1. Therefore, we have this situation. Do you see that F2 and H2, they are all equal to the same thing? So from a logical point of view, it means they are equal. So from a logical point of view, therefore we can conclude that F2 is equals to H2. And since F2 and H2 are alternate angles, therefore DF is parallel to HB. So this is how we then prove that the lines are parallel. And then now we know that DF is parallel to HB. And then the question C says now we need to show that DFBH is a parallelogram, right? Now this is not going to be difficult. We just say I claim that DF is equals to BH. Reason, because we just proved that triangle AFD is congruent to triangle CHB. So we just showed that. Let me create a border here. We just showed that the triangles are congruent, right? And then we also showed that DF is parallel to BH or HB. This one is proved. We proved it above, right? Therefore, we can conclude that therefore DFBH is a parallelogram because a pair of opposite sides are equal and parallel. That's what we needed. Then we are done with the problem. And then this is the last problem. Problem 6 says in triangle M and P, angle M is 90, S is the midpoint of MN. S is the midpoint of Mn, meaning Sm is equals to Sn. Very important to note that. And then we are told that T is the midpoint of Nr, meaning Nt must equal to Tr. Prove that U is the midpoint of Np. Okay? Prove that U is the midpoint of Np. In order to have enough space, I'm gonna solve it on top of this diagram. I will start the solution on top of the diagram. So now we are given that Sn is equals to Sm. So this one is gonna be given, and then Nt is equals to Tr is gonna be given. Therefore, I claim that St is parallel to Mr. Reason, midpoint theorem. The midpoint theorem, right? And then after this, then I claim that Su is parallel to MP. Reason? Because ST lies on line SU, right? And MR lies on line MP. So this is our claim, right? So then we know that they are parallel. So it means we now know that they are parallel. So I also claim that TU is parallel to RP. The same principle is what? Is because of TU lies on SU and RP lies on MP, right? Therefore, we can now use the converse of the midpoint theorem. Then since now we have Nt is equals to Tr is given, right? And then we know that Tu is parallel to Rp. We just proved, right? Therefore, it follows that Nu is equals to Up. Reason, converse midpoint. Therefore, we can conclude that U is the midpoint of NP. And then the second one says if ST is equals to 4 centimeter and the area of triangle SNT, the area of triangle SNT is 6 centimeters squared, calculate the area of triangle MNR. So if ST is equals to 4 centimeters, so ST we are told that is 4 centimeter. This is ST is 4 centimeter. And the area of triangle SNT is 6 centimeters squared. Calculate the area of triangle MNR. So in order to calculate the area of triangle MNR, we need to have the length of MR, right? We need to have the length of MR. So what is the length of MR? Yeah, so then now we face this problem right here. So I'm gonna use a red color to do the solution of B. I'm gonna start it at the top because of space on top of the diagram right here. So to do that, we're gonna say, okay, since we are given that NS is equals to SM, right? And NT is equals to TR. These are given, right? Therefore, I claim that ST is 1 over 2 MR. Reason, midpoint. Therefore, since ST is 4, and then we want MR, we can just divide both sides by 1 over 2. And then MR is going to be 8 centimeter. So it means we have 8 centimeter here. So now that we have 8 centimeter there, then we can now find the area of triangle MNR. So then I'm going to say area triangle MNR, the area of triangle MNR over the area of triangle SNT is equals to, when we do area of a triangle, we know is 1 over 2 times base times height. So we have 1 over 2 times base. What is the base of triangle MNR? The base is 8 centimeters, so we're going to have 8 centimeter as our base. So we have 8 centimeters as our base. What is the height of triangle MNR? The height is MN. So this is the height right here. So the bigger triangle. So then we know the height is MN. So we're going to say multiply by MN all over 1 over 2 times the base of triangle SNT is 4 centimeter times the height of triangle SNT. The height of triangle SNT is what? Is SN. So triangle, this is the height of triangle, is SN. And we know that the angle here is 90 degrees because of, we know according to the midpoint theorem, these lines are parallel. So these angles are corresponding angles. So don't forget that. So then we have SN here. Right? But we also know something. We know that MN comes from SN plus SM, but NS is equals to SM. Therefore, we can write MN in terms of SN. So it means we can say that 1 over 2 times 8 centimeter times 2 SN, because of NS is equals to SM. So it means MN is 2 times SN. So divide by 1 over 2 times 4 centimeter times SN. Then now we can cancel out some things. 1 over 2 will cancel with 1 over 2, centimeter will cancel with centimeter, and then SN will cancel with SN, and we are left with 8 times 2 over 4. 8 times 2 over 4 is how much? 8 times 2 is 16, and then 16 over 4 will give us 16 divided by 4 is 4. So we have 4 here. And then now we know that we know that the area of SNT is given is what? Is 6, right? So then we can just come here and say area of triangle MNR over 6 is equals to 4. and therefore we say over 1 here, and then we do cross multiply, right? When we do cross multiply, then we have 4 times area triangle MNR is equals to 6 times 4 is 24, right? And we divide both sides by 4. So then we find that the area of triangle MNR is equals to 24 divided by 4. Divided by 4. So I think we made a mistake here. Let me fix this. So here we don't have any 4 here. Yeah, so this is supposed to be only 24. Sorry, it's a mistake. So the answer is gonna be what? 1 times that. 1 times area of triangle MNR is just gonna be area of triangle MNR. It's not gonna change. And then we have 6 times 4, and then we have what? 24 centimeters squared. And this will be the area of triangle MNR. Yeah, then you can see that we just proved that. These problems are very interesting because they teach you logical reasoning. You are able to reason logically, come up with solutions using critical thinking and using what you are given to arrive at the answer. And the last question is 6.6c, which says prove that the area of triangle MNR will always be 4 times the area of triangle S and T. Let ST equals to X. So let ST equals to X. So we're gonna say ST is X, right? Let me use a different color in this case. So ST in this case is X. We're gonna say is X. And then SN, we're gonna take SN as Y. So prove that the area of triangle MNR will always be 4 times the area of S and T. How are we gonna do that? The same way. So we're just gonna say area triangle MNR over area of triangle SNT equals to 1 over 2 times. What is the base of triangle? What is the base of triangle MNR? It's gonna be 2x, right? Why is it 2x? Because of the midpoint theorem. Remember, the midpoint theorem says that ST is half of MR. So if ST is X, it means MR must be 2X. So in this case, we know that MR is 2X, right? So then we have the base is going to be 2X here. So we have base of MR is 2X and the height is MN. And over area of triangle SNT, we have 1 over 2 times base. The base is X, and then the height is what? Is SN. But we know that MN is what? Is 2SN. So we're going to have 1 over 2 times 2X times 2SN over 1 over 2 times X times SN, right? But SN is Y, so we can replace Sn by y, and then we have 1 over 2 times x times y. Then we see that 1 over 2 cancels with 1 over 2, y cancels with y, and x cancels with x, and we are left with what? With 2 times 2 over 1 at the bottom, so we have 4. So then we can conclude that the area of triangle MNR is equals over area of triangle SNT is equals to 4. Therefore, when we write it correctly, then we can say therefore triangle area of triangle, let me write it the correct way. So therefore, if you do over 1 here, you do cross multiply, then you're gonna have area of triangle MNR is 4 times the area of triangle SNT. Then we have proved